When a problem asks you to solve for an SSA triangle, you're given three pieces of information. First, you're given the angle, or one angle, and second, you're given the side opposite the angle, and third, you're given the side next to the angle, or one of the sides next to the angle. So the first thing you do when you get one of these problems is draw a diagram. And there's three possible scenarios for the diagram. So first, angle A could be 90 degrees, or angle A could be obtuse, or angle A could be acute. So first, I'm going to go through the case where angle A is 90 degrees. So in this case, this would be angle A. This would be the side next to angle A. And we know that side C is somewhere on this line. It could be over here, or it could be like this long, or this long. And then we know that side A connects this point to side C somehow. So the first thing you do when you get one of these things is you look at side A and see if it's longer than side B. If side A is the same length as side B or shorter, there's no way it could ever reach side C. Or there's no way it could ever complete the triangle. So if side A is longer than side B, then there's exactly one possible scenario for this triangle, no matter what. Because if you draw side A from this point down here, that's one length, and then if you drew it from here to another point on the side, it'd be either longer or it'd be shorter. So there's only one possible scenario when you have a 90-degree angle and the side opposite the angle is longer than side B. Because if side A is the same length as side B, then it would never hit the side to complete the triangle. The next possible scenario is when you have an obtuse angle. So I'm just going to sketch it out. Okay, so this is angle A. This is side B. And we know what this angle is. We just know that it's obtuse. I'm not using real numbers here, but you can still get the general idea. So once again, for this side right here, we know that side A, if the triangle is completed, it would hit somewhere on this side. We just don't know which point it would hit. And once again, the same thing as we did for the right triangle. The first thing you do is check to see if side A is longer than side B. Because if side A is shorter than side B, once again, it would never be able to complete the triangle. You could get like here or here, but you wouldn't be able to complete the triangle while preserving this degree right here. And then once you figure out if side A is longer than side B, then there's exactly one possible way that it could complete the triangle. Because if you think about it, let's just say this is side A right here. That's how long it is. If you were to rotate it this way, there's only one place that the side would hit this side here. So there's only one possible way it could complete the triangle. So once again, for obtuse and 90-degree angles, first check to see if side A is longer than side B. If side A is the same length or shorter, there's no possible triangle. If side A is longer, there's one possible triangle. Okay, now moving on to the acute angle. So when you're given the acute angle, there could be three possible scenarios. Either there's no triangle possible, there's one triangle possible, or there's two triangles possible. But no matter what, the first thing you do is draw the angle and draw all the information that you know. So let's just say, okay, so angle A, angle B, and you know this angle, you know what the measure is. So you know that side C must be on this side here, because side C must go in this direction in order to make this angle with side B. But once again, you don't know exactly where side A would hit this side C right here. Okay, so in this case, the first thing you do is find the height of the triangle. or the altitude, because in order for side A to hit side C somewhere, side A must be at least this long. Because if I'm going from this point to side C, the shortest possible distance is directly perpendicular with side C. So this is the shortest possible distance that I could go in order to hit side C. So if side A is not even this long, then it would never ever hit side C, and there'd be no triangle. And we can use basic trigonometry to figure out the height of the triangle. So in this case, we know that sine is opposite over hypotenuse. So sine of that angle that we know, I'll just call it angle x. Sine of angle x is equal to h over b. And then sine of angle x times b is equal to h. So, I mean, in the problem they give you what, oh, that should be angle A, never mind. So in the problem, they give you angle A and they give you side B, so you can do this to figure out the height of the triangle. And once you figure that out, if length A is longer than the height, or no, if length A is exactly the same length as the height, then there's only one possible triangle that you could make. Because the only possible triangle you could make if length A is the same as the height is drawing length A straight from this point down to here. If you were to draw length A like this, it would be longer than h. And like this, it would also be longer than h. So if length A is the same length as the height, then there's only one possible triangle. You just have a right triangle. However, if length A is longer than the height, then there could be one or two possible triangles. So if length A is longer than the height and also longer than length B, then there is only one possible triangle. Because if you think about it, if length A goes out to here and you rotate this around, you would hit side C at one point and you wouldn't hit it again because you would just keep going this way. So there'd be only one possible triangle in that case, if side A is longer than side B and also longer than the height. However, if side A is longer than the height, but it's shorter than length B, then there are two possible triangles. So in this case, you could have side A going from this point down to here to make a triangle, or you could also have it going from this point down to here to make another triangle. So if side A is longer than the height, but shorter than side B, then there are two possible cases. And I think this goes over the basic ways to tell how many different triangles there are.